Hello everyone, today we will discuss one of the most important oxidizing reagent, that is the Jones reagent. It will oxidize the alcohol to the carbonyl group. So the chromium trioxide, acetone and the aqueous sulfuric acid forms the Jones reagent. When these three chemicals are involved, that is known as a Jones reagent. The chromium trioxide, the acetone and the aqueous sulfuric acid. Okay, the addition of acetone reduces over oxidation of the chromium 6 reagent. Remember that the addition of acetone is important because it will reduce the over oxidation of chromium 6 reagent. The primary alcohol does not give the carboxylic acid in the Jones reagent. When the Jones reagent is present, there will be a no over oxidation with the primary alcohol. So the primary alcohol get oxidized to the aldehyde. Remember that the primary alcohol get oxidized to the aldehyde. This is the one of the most important property of the Jones reagent. But when we have the chromic acid as oxidizing agent, there will be a over oxidation of this primary alcohol. The double bond and triple bond are unaffected in the case of Jones reagent. But in the case of chromic acid, the double bond and triple bond get also oxidized. But here you can see that this is the secondary alcohol which is oxidized to the ketone. The double bond and the triple bond is remain as it is in the product. The double bond and the triple bond is remain as it is in the product. The next important factor regarding the Jones reagent is that the acid level groups are unaffected. Remember that the acid level groups are unaffected in the Jones reagent except the epoxide. Epoxide is affected when the Jones reagent is oxidized. When our substrate has the epoxide, it will get affected by the Jones reagent. The next and the most important property of the Jones reagent is that it is a non-selective oxidizing agent. Remember that it is a non-selective oxidizing agent. It will reduce primary alcohol as well as the secondary alcohol. So here you can see that the chromium trioxide, the aqueous sulfuric acid, and here the acetone plus alcohol. There will be a 1:1 ratio. When there will be a 1:1 ratio of chromium trioxide with the aqueous sulfuric acid and with the acetone and water, produce the aldehyde from the primary alcohol. If there will be a no 1:1 ratio, there the over oxidation will be carried out. Acetone plus alcohol, chromium trioxide, aqueous sulfuric acid. 1:1 ratio is the most important point. If 1:1 ratio is not present, there will be a definitely over oxidation. Okay, now one of the most important point is that the byproduct of this oxidation reaction is the chromium dioxide, which is the toxic product. The random addition to the substrate leads to the explosion. So remember that the random addition leads to the explosion. Now we will see some basic application regarding this. Here in the first application, the first example, you can see that this is the secondary alcohol and this is the primary alcohol, but it is a non-selective oxidizing agent. It will reduce secondary alcohol as well as the primary alcohol. So the secondary alcohol get reduced to the ketone and the primary alcohol get reduced to the aldehyde. In the second example, here you can see that the secondary alcohol is present and the epoxide is present. So when the Jones oxidization is carried out, the epoxide is also get affected. So here the alcohol formation will carried out, and here this OH group, the secondary alcohol, is converted to the ketone. As I earlier said, the acid level groups are unaffected but the only epoxide get affected. Here this is also acid label group, but this group is unaffected during the Jones oxidation. Now we will see the most important point, that is the mechanism of this reaction. This is the chromium trioxide, this is the H3O molecule. The lone pair of electron attacked over this hydrogen atom, and this double bond gets shifted here. The positive charge over the oxygen is unstable because the oxygen is the second most electronegative atom. So okay, here you can see that here the positive charge over this oxygen is present now. Here in the you can see that this is the secondary alcohol. Now the lone pair present on the oxygen will attack over this chromium, and this double bond gets shifted here toward this oxygen. So this oxygen become neutral. Here you can see that, so this complex is formed here. This hydrogen remain as it is. 2-methyl group is also present as it is. Okay, the OH group is present because this double bond shifted towards the oxygen atom, but this oxygen atom carries the positive charge. Now the water molecule abstract this hydrogen, okay, and the positive charge is now the neutral because the lone pair the bonding pair of electron is shifted toward this oxygen atom. So there will be a minus H3O positive. Here this is the chromate ester. The chromate ester formation is carried out. Now this double bond gets shifted towards this to this hydrogen atom. So this hydrogen atom is transferred to this oxygen. This bonding electron pair is shifted towards between the carbon and oxygen, and this bonding electron between the chromium and oxygen is shifted towards the chromium. Remember that this double bond, this double bond will attack over this hydrogen atom. Okay, the bonding electron between the hydrogen and carbon is shifted towards the carbon and oxygen, and this bonding electron which is present in the chromium and oxide is transferred towards the chromium atom. So here you can see that there will be a formation of ketone and H2Cr O4. The chromic acid will be formed here.